Hi, I'm Neil, representing my team for this project, and today we're going to be talking about our experiment measuring the correlation between UV intensity and carbon monoxide. The goal of this experiment was to analyze the relationship between ultraviolet light intensity and carbon monoxide levels and use that to gain a better understanding of the relationship between UV light and smog in general. The multiple locations of our group members afforded us the ability to analyze data in multiple locations with different amounts of carbon monoxide and different average UV intensities. Before conducting our experiment, we hypothesized that CO and UV levels would have an inverse relationship. We expected that as CO increased, more particulates would be in the air and would reflect more UV light. As CO is a main reactant in the formation of smog, it reasons that as CO increases, smog will too.
To accomplish the scientific goals of this experiment, these three sensors were used. The carbon monoxide sensor on the left had an analog voltage output and was taken to be a measurement proportional to the amount of smog. The UV sensor in the center also had an analog voltage output and was calibrated to find UV index using the UVImate app. The temperature and humidity sensor on the right had a digital output whose values could be verified with local National Weather Service measurements. This sensor was used because temperature and humidity can sometimes affect the carbon monoxide sensor's measurements. All three sensors had the same pinouts, so they could all be implemented using this schematic. The Arduino was used as the 5-volt source. All three device outputs, analog and digital, could be read into the serial monitor simultaneously. Here we have the device implemented with the sensors on the right and the Arduino board and expansion module on the left.
During the testing period, each member of the team took their sensor outside under direct sunlight at least 5 times each day for 10-minute periods. During the 10-minute period, the UV sensor was rotated slowly to change the angle towards the sun. The temperature and UV index shown on the UVImate app were also recorded, along with the cloud conditions. The data output onto the Arduino serial monitor was copied into a plain text file. Then, a Python script was used to turn the file into a format that could be easily read by MATLAB. Using MATLAB, the averages for the carbon monoxide, UV, temperature, and humidity values were found and put into a spreadsheet. Using the UV index and the UV sensor output, a calibration curve was made.
The data from each of the 5 locations is shown here, with calibrated UV index on the y-axis and carbon monoxide level on the x-axis. We were expecting an inverse trend between the two, but as you can see, there is no general trend between carbon monoxide and UV. Based on the data shown in the graph, we concluded that UV index and CO are uncorrelated. However, upon visual inspection, it appears that the data from each location is clumped into a smaller range of CO values. We further looked into this by creating the following table. This table shows the minimum, maximum, and range of CO values for each location. This was useful for us because it allowed us to see if there were similar CO levels in locations that were geographically closer together. For example, Redwood City and Gilroy are about 80 kilometers apart and had CO levels in very similar ranges. An additional observation is that Evanston has a larger range of CO levels than all of the other locations. This could have been because of different sensitivities between each of the sensors.
Since we didn't find a correlation between UV intensity and carbon monoxide levels, we looked at other recorded weather conditions that could have impacted either variable. These histograms show the general trends for CO across different cloud cover conditions. Interestingly, cloud cover didn't seem to impact CO levels, as the samples are roughly equally distributed across the CO values. Further analysis revealed that cloud cover did have a significant impact on UV. This correlation is plausible because increased cloud coverage in the sky would block UV radiation from the sun. We additionally analyzed temperature and humidity data and found no patterns except a slight positive correlation between UV and temperature. Overall, our data did not support our hypothesis because we did not find an inverse relationship between CO and UV. Further research into the trends between UV, smog, and weather conditions would involve collecting more data over a longer period than a couple weeks. Additionally, higher quality sensors that were outside of the budget of this project could measure other types of pollution and gases.